Welcome to Maths Minders Academy. Today, we are happy to have a class with you. We are going to be doing solution to questions number 41 to number 50 of Waec November 2010. This is the last part, that's part 5 of this 5-part video series. If you have not watched part 1, part 2, part 3, and part 4, we are going to drop the link of these videos in today's video description. So you can go check it out in this video description so that you will be able to see solution to questions number 1 to number 40. So we are going straight to question number 41. If you have not subscribed to our channel, please go ahead, subscribe, click on the notification bell so that each time we release a new video, you'll be among the first to access it. Share this video, like it, and then we want the YouTube algorithm to send these videos to as many students as possible. That's why we are pleading with you to please subscribe. That way, help the algorithm to deliver this video to many students who might actually be in need of these solutions. So let's proceed to question number 41. We want to calculate the total surface area of a cube of size 5 centimeters. So the TSA, total surface area, that's TSA of a cube, is gotten by this formula, that is 6 times one of the sides raised to power 2. And that is going to be 6 times, the side is 5 centimeters, so we have 5 raised to power 2. That will give us 6 times 25. And 6 times 25 is actually 150 square centimeters. So that is the total surface area of this cube of side 5 centimeters. That's option A. We'll mark that option and we proceed to question number 42. Here, question 42, we are told that in the diagram, PQR is a tangent to the circle at Q. If the side QT is equal to the side ST, and we can see those two sides are marked, and angle SQR is given at 62 degrees, we are required to find angle PQT. So let's go and mark angle PQT. That's what we need to find. So we are looking for this angle here, angle PQT. That's this angle here. This is the angle we are looking for. Now, if we apply the theorem that connects chord and tangent, we know that this line QS is a chord. Let's not forget, line QS is a chord. So there's a theorem here that says the angle between the chord and the tangent is equal to the angle in the alternate segment. So this 62 here is also equal to this angle here. So this angle is 62. Now the alternate segment, this is the chord actually cut off a segment here. This is a segment. So the alternate, that is the segment, this is called minor segment. So the alternate segment is the major segment, which is where this triangle is finally built. You know, this triangle has this chord. So the remaining two sides are used to form an angle in the major segment. So the angle between the chord and this tangent will be equal to this angle formed in the major segment. So that's the theorem. Now, looking at this triangle TQS, it's an isosceles triangle. We say so because the side TQ and the side TS are equal. So anytime a triangle has two equal sides, then the triangle is called isosceles triangle. And the theorem now goes on to tell us that the base angles will be equal. So the base angles will be equal. That means this angle here are called the base angles of an isosceles triangle. They are equal. Now, using this theorem, we can now add that these three angles here will add up to 180 degrees because the sum of the angles in a triangle is 180 degrees. So if I add 62 degrees plus theta plus theta, it gives me 180 degrees. I have 62 plus 2 theta equals 180 degrees. 2 theta equals 180 degrees minus 62 degrees. 2 theta is going to give us 100 and if we look at it, that's going to give us 180 minus 62 is 118 degrees. So theta is 118 all over 2, and that will give us 59 degrees. That's theta. And now, if theta is 59, look at this angle too. This angle theta, this particular angle TSQ is in the major segment. This is another minor segment here. This is another minor segment. This segment here is a minor segment. So this theta is also the same here. So here we are also going to have an angle whose value is equivalent to theta. So it means, therefore, that angle PQT is equals to theta, which we have found to be 59 degrees. So mark that option. That's option D. And we'll proceed to the next question, which is question number 43. Question 43 says, in the diagram, PQTV is a parallelogram. Now, angle TRS is 110 degrees, which is given, you can see it on the diagram. And angle PVT is 80 degrees. We can also see the 80 degrees here. Calculate the size of angle QTR. Let us mark angle QTR. It is this angle here. Now let's give a value. Let's call this angle alpha. Okay, now we can have another angle here. Of course, we know that PQRS is a straight line. Angle on a straight line will add up to 180 degrees. So we have 110. So the remaining angle to complete 180 will be 180 minus 110. That gives us 70 degrees. So inside here, we have 70 degrees. Now, if we look at this parallelogram, the angle P here is 100 degrees. How do we get it? Angle PVT plus angle VPQ will give us 180 degrees. They are called co-interior angles. So they will add up to 180 degrees. So since we have PVT as 80, we can get angle VPQ by subtracting 80 from 180. If we subtract 80 from 180, we have 100. Now, look at this angle here. It's also 100. Why is it 100? It's called corresponding angles because the line PQ and the line VT are parallel. So we say since PQ is parallel to VT, then angle VPQ is equal to angle TQR, and that is corresponding angles. So it means that angle QTR is also 100 degrees. Now, looking at this triangle, so if we consider this triangle TQR, we have two of the three angles given. So we already have 170. This third one is alpha. So in this triangle, if I add alpha, add 100 and add 70, I expect to get 180. That is the sum of interior angles in a triangle will give 180 degrees. So alpha plus 170, 100 plus 70 is 170, equals to 180 degrees. So alpha itself is going to be 180 minus 170, which is 10 degrees. So this alpha, this angle we are looking for here, has a value of 10 degrees. And if we check the option, we can see that option D is the correct option. So we mark that and we'll proceed to the next question. Question number 44. What is the locus of a point P which moves in a plane such that it is always 4 centimeters from a fixed point O? So if we have a fixed point, this is a fixed point. So anywhere this arbitrary point is, it will be 4 centimeters away from O. So you can actually take any of these positions. You can take. So at the end of the day, the pattern being created here is a circle. It's a circle because look at from any point to the fixed point is 4 centimeters. 4 centimeters. Wherever the locus is, wherever it is. So wherever the point is, the locus is the track that the point is making. The point P can be anywhere. So we can have P here. We can have P1. I have P2. So this is the movement of P, P3. P can move P4. P can move P5, just like that. P6, and it will continue the movement. Now, each time we measure point O to where P is, it gives us 4 centimeters. When we take the locus, that is the track made by P, the track will form a circular pattern. The track will form a circular pattern. So we will now define this locus as a circle center O, radius 4 centimeters, which is option A. So option A is the appropriate answer to this question. We proceed to question number 45. Question 45. The diagram shows a cone which was formed from a sector of a circle calculate correct to the nearest degree the angle of the sector of the circle from which the cone was formed. So now let's create some relationship. We have sector. We have sector. We now use this sector to make a cone. So let's assume this is our cone here. Now, let's call this sector, the radius of this sector, let's say is big R. When we fold this sector, we will observe that the radius of the sector will become the slant height of the cone. The radius of the sector will become the slant height of the cone. Now, this length of arc, the sector has an arc, AB. The length of arc becomes the circumference of the circular base of the sector. This length of arc, AB, becomes, that means this AB becomes 2 pi r, where r is the radius of the base of the sector, of the cone. So this length AB, length of arc, becomes 2 pi r. That means, and we know that length of arc length is given as theta over 360 times 2 pi r, where this big R is referring to the radius of the sector. Now we say this will now be equal to the circular base of the cone, which is the circular base, that's the perimeter of that base, which is 2 pi r. Now, let us look at something here. We can divide both sides by 2 pi to create some relationship that will be very useful here. We can decide to divide this by 2 pi, divide this by 2 pi. What do we have? This 2 pi, we cancel this, this will go. That means the radius of the circular base of the cone, the radius of the cone is equal to theta over 360 times the radius of the sector. Now, if we are looking for the angle of the cone, that is the angle of the sector, which is this theta here. If I make theta the subject, I can cross multiply this. If I cross multiply, I'm going to have 360r equals big R theta. Remember that the big R is the radius of the sector, while small r is the radius of the cone. So if I make theta the subject, theta becomes, if I make theta the subject, theta becomes 360r over big R. Okay, that is 360 times the radius of the cone over the radius of the sector. Now, using this formula we generated to find the angle of the sector, it's going to give us 360 times the radius of the cone is 5 here. So times 5 all over, if we look at big R, which is the radius of the sector, if you look at it, it's given here, we are told that we have established here before that the radius of the sector and the length, the slant height of the cone, they are the same. So this sector here that has big R is the same thing as 13. This 13 here is the slant height of the cone. It's still the same thing as the radius of the sector. So we pick it up here. That means this denominator is going to be 13. So when we now multiply 360 by 5, and we now divide our answer by 13, what will that give to us? It will give us 138.46. So we have theta equals 138.46 degrees. But we are asked to correct our value to the nearest degree. So if you run this up to the nearest degree, you're going to have theta equals 138 degrees. And we check through the options, we see that option D is 138 degrees. We'll mark it as the correct option. If you are finding value in today's video tutorial and you have not subscribed to our channel, go on, click on the notification bell so that each time we produce a new video, you will have access to it. Subscribe, share this video, like it, go to the comment section and tell us how you feel about this video. Let's get your feedback so that I'll be able to serve you better. Let's proceed to question number 46. Each interior angle of a regular polygon is 144 degrees. How many sides has the polygon? Now, number of sides of a regular polygon is given as 360 over each exterior angle. Now, we also need to know that exterior angle plus interior angle will add up to 180 degrees. Because if you have a polygon, let's give an example now. Let's draw a polygon. This is a polygon here. Now, you will see that this is interior, this is exterior. This is interior, this is exterior. They all line on a straight line. This is interior here, this is exterior. This is interior, this is exterior. So the interior and the exterior all line on a straight line, and their sum will give 180. So here we have interior to be 144. That means exterior, we say exterior, since interior is 144, it means that exterior angle is going to be 180 minus 144 degrees. That will give us 36 degrees. So number of side is 360 all over 36, and that will give us 10. So this polygon in question has 10 sides, which is option C. We'll mark that and proceed to question number 47. Question 47 says, a coin is tossed 3 times. What is the probability of having 3 heads, 3 heads, or 3 tails in this experiment? So let's look at if this is tossed once, we'll have head, tail. Now, if we take the second one, if we do it again, we have head, tail. Here, we have head, tail. This is the second. Now, if we take the third one, we are going to have this, this, which is head, tail, head, tail. Coming here again, we have head, tail. Here we have head, tail. So let's look at the outcome. The outcome now, we have head, head, head. So we have head, head, head. We have head, head, tail. So there's head, head, tail. There is head, tail, head. So we have head, tail, head. There is head, tail, tail. So we have head, tail, tail. Then there is tail, head, head. So we take tail, head, head. There is tail, head, tail. So we have tail, head, tail. We have tail, tail, head. So we have tail, tail, head. And then there is tail, tail, tail. So we have tail, tail, tail. Now, our focus is where we have 3 heads. So let's look at it. This is 3 heads. This is 3 tail. So this happens twice out of an outcome of how many? 1, 2, 3, 4, 5, 6, 7, 8. So out of the 8 possible outcomes, this incident happens only twice. So that's 2/8, which can be reduced to 1/4. And that's option C. So mark option C, and we proceed to question number 48. Now, question 48. We are given this triangle here, PSR. And then there's another smaller triangle attached to it, that's triangle PTQ. So they said in the figure, angle PQT is equal to angle PSR, which is 65 degrees. And angle PTQ equals to angle PRS, which is 45 degrees. Which of the following statements about triangles PTQ and PRS is or are correct? So now, these 2 triangles, we are going to establish that they are similar. Once we establish similarity between them, then we will employ the law governing similarity of shapes. And that law says that if 2 triangles or if 2 shapes are similar, then the ratio of their corresponding lengths will be the same. So here, of course, the 2 triangles have a common angle at this vertex, at this point here. Let's use this red to mark it. Okay. Let's do something here. So let's mark it red. Now, there is another angle that is also equal. Let's mark it blue. That is where we have 45 in the big triangle. The small triangle also has 45. Then the 3rd angle is, let's leave it as black. That is 65, 65. Now, when 2 triangles are equiangular, then they are similar. Let's write it out. When 2 triangles are equiangular, that is, they have equal angle, equiangular, then they are similar. So we have established similarity here using this markup. So now, if they are similar, we want to now check this condition I, and I. Which of them is correct? So let's look at I. Now, that is telling us that PQ over PT Let's look at PQ. PQ is from P to Q is where we have red. So now we are going to look at red and assign a number to it. Let's say 1. For the blue color, can call it 2. And for the black, we can call it 3. So now, if you look at PQ, let's test the first one. Let's check that ratio out. PQ, that is from P to Q, is red mark to black mark. Red, that is 1 to 3. So let's call it 1, 3. If you look at PT, PT is red, blue. That is 1, 2. Okay, so now, of course, this ratio, where you have even 1, 2, and 2, 1, they still they identify the same size. It's only incongruency that this may actually matter, but in similarity, if you have a side designated 1, 2, and it can also be 2, 1, it's still referring to that side. Now, let's look at PS. From P to S, that is red to black. Red to black is 1, 3. 1, 3. Now, let's look at PR. From P to R is red to blue. Red to blue is 1, 2. Red, blue, 1, 2. So we can see that what we have here is the same as what we have here. So we mark this, like this is correct representation. Let's go to number 2 condition given. PQ, let's look at PQ again. Red, black. Red, black, that's 1, 3. PQ here is 1, 3 over TQ. TQ, blue, black. Blue, black is 2, 3. Now, let's look at PS. PS is red, black. And red, black is 1, 3. Now, let's look at SR. SR is black, blue. Black, blue is 3, 2. 3, 2, which is still the same thing as 2, 3, because it's still the same line. The same line that we call SR can be the same as ROS. It's the same. We are not dealing with congruency here. So this is similarity, and we are talking about ratio of side. So if I take the side SR, it's still the same value I will get if I take ROS. So this is correct. We'll mark it. Now, if we look at condition number 3, is it a valid condition? Let's go and test it. Number 3. So we have marked this. We have marked this. So the third one now, which is I. We want to test this. We have TQ. That is T to Q. That is blue to black, which is 2, 3. So we have 2, 3 all over SR. SR is black, blue. Black, blue is 3, 2. Okay, let's see what we have here. PQ. PQ is red, black. And red, black is 1, 3. So TQ. TQ is blue, black, and blue, black. Here is 2, 3. So yes, we can see that there is agreement. Of course, this is still the same thing as 3, 2. But if you look at the numerator has given us a wrong line. These two lines cannot, these 2, 3 and 1, 3. Look at, it can be the same. The line designated 2, 3 is line, that's where you have blue, black. That's line TQ. And look at PQ. So they don't correspond. So at the end of the day, we knock out this doesn't correspond. It moves different numbers. So we now have I and II, which is option D. I and II only. It's only this option D that satisfies the information. We move on to question number 49. In the diagram, O is the center of the circle with radius 10. Of course, so this is 10. This is 10. Then if angle QKR is 90 degrees and PK is 6, find KQ. So this is also 6. Let's take notes, because this isosceles triangle and this is a bisector. The line drawn from the center to meet PR is a perpendicular bisector. So he divides it into 2 equal parts. Now, also, don't forget that the line segment OQ is equally 10 centimeters. From center to circumference is radius. What I'm looking for is KQ. So the length of this KQ is equals to OQ minus OK. So once I do that, if I can cut it, so of course, look at it. You have a line, and you call this O. You come here, you have K here, and then you have Q here. If you are looking for KQ, it's going to be O to Q minus OK. Once you get it, you are good to go. Now, we are going to use Pythagoras here to get OK. So let's rub off this and apply Pythagoras. So we can say by Pythagoras. By Pythagoras said in a right angle triangle, the square on the hypotenuse is equal to the sum of the square on the other two sides. 10 squared is equal to OK squared plus 6 squared. So this is 100 equals OK squared plus 36. So OK squared is equals to 100 minus 36. That gives us 64. So OK is equals to square root of 64, and that gives us 8. So if it is 8, and I said OQ is 10, that means KQ, which is what we are looking for, is going to give us 10 minus 8, and that is 2, because OQ is 10. Remember that we said that KQ is equals to OQ minus OK. So that means it's going to be 10 minus 8. That gives us 2. And that's option A. So we mark option A and we now proceed to the last number, which is question number 50. Question 50 said the probability that a boy passes an examination is 0.3 and that of a girl is 0.4. What is the probability that a boy and a girl will pass? So a boy, this probability that boy passes the exam is 0.3. So probability girl passes this exam is 0.4. So what we are now looking for is probability that a boy and a girl pass. That's both. So probability that both of them pass is going to be 0.3 times 0.6. That gives us times 0.4. This is 0.4 here. That a girl pass is 0.4. Let's correct it. Sorry for that error. So we have corrected it. So probability that both pass the examination will be 0.3 times 0.4, which is going to give us 0.12. And that is option B. So this is how far we can go, and we have fully completed solution to question number 1 to question number 50 using a 5-part video series. Go check them out. If you have any part of this solution that you don't understand, go to the comment section, tell us about it. We have our contacts. Look at the video description. You can reach us out one-on-one. We have our email. You can communicate to us. We'll find a way to make it clearer. It is our desire to reach out to as many students as possible using this medium, just to encourage students and to let them know that learning mathematics can be quite interesting. What you can help us do, if you have not subscribed to our channel, is to please subscribe to our channel so that the YouTube algorithm will help to place this video in the front of many students who might actually want to have it to help them in preparing for their examination. Please help us do this. It is our way of helping, a lot of our learners, our way of giving back to the society. Please help us subscribe if you have not done so. Like this video, make your comment. Your comment will be a feedback, and it will help us to make improvements in order for us to serve you better. Thank you very much. We'll be looking forward to having another wonderful class with you when we'll be treating another paper year. Be there with us when we'll have that tutorial class. This is Math Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams, caught in the